Imagine looking up at the night sky and realizing that everything you see, every star, every planet, every galaxy, has a story to tell, a story that has shaped life here on Earth in ways we are just beginning to understand. From the explosive birth of the universe to the first footsteps on the moon, space has been the ultimate frontier, redefining what we know about our existence and sparking discoveries that have transformed technology, science, and even the way we see ourselves. In today's journey through 30 monumental space events, we will uncover the groundbreaking moments that forever altered the course of human history. These events not only pushed the boundaries of knowledge but also revealed hidden truths about our place in the cosmos. By the end of this video, you will see how these awe-inspiring milestones connect us to the vast expanse of the universe and challenge us to imagine what comes next. Are you ready to explore the events that changed everything? Let's begin. Now turning to the origins of everything, the story begins over 13 billion years ago with the Big Bang. This monumental event wasn't just an explosion. It was the rapid expansion of an unimaginably dense and hot point that gave birth to the universe as we know it. From this singular moment, time, space, matter, and energy all came into existence, forming the foundation of all cosmic structures. In the first fractions of a second, the universe expanded exponentially, cooling just enough for particles to combine and form the first simple atoms like hydrogen and helium. These building blocks would later coalesce under gravity to create stars, galaxies, and every celestial body we observe today. The Big Bang not only set the stage for the cosmos, but also gave physicists and scientists an enduring mystery to unravel. Decades of research, from cosmic microwave background radiation studies to particle physics experiments, have provided glimpses into the mechanisms of this epoch-making event. Yet, many questions remain unanswered. What triggered it and what existed before it? These puzzles continue to challenge even the brightest minds, reminding us that the story of the universe is far from fully written. Understanding the Big Bang doesn't just help us comprehend where we come from. It drives forward the quest for knowledge, fueling explorations that probe the very edges of existence. With this profound beginning in mind, let's move forward to an invention that first brought the stars closer to human eyes. Now turning to the invention that transformed humanity's understanding of the cosmos, let's journey to the year 1609, when Galileo Galilei revolutionized our view of the universe with his telescope. Using a simple yet groundbreaking design, Galileo crafted a device that could magnify distant objects up to 20 times. For the first time in human history, the heavens could be seen in stunning detail, and what Galileo observed through his lens would forever change our place in the cosmos. He discovered that the moon was not a smooth, perfect sphere as once believed, but a rugged landscape with mountains and craters. He observed the four largest moons of Jupiter, Io, Europa, Ganymede, and Callisto, now known as the Galilean moons, orbiting the giant planet, a discovery that challenged the long-held belief that all celestial objects revolved around Earth. Galileo also revealed that Venus went through phases similar to the moon, providing critical evidence that supported the heliocentric model of the solar system, which positioned the Sun, not the Earth, at the center. Additionally, his observations of Saturn showed its unusual shape, which we now understand as its iconic rings. These findings not only debunked the geocentric view of the universe, but also laid the groundwork for modern astronomy. Galileo's telescope was more than a tool. It was a window into a universe far more complex and dynamic than anyone had imagined. This invention did not just advance science, it sparked a paradigm shift, challenging centuries of dogma and inspiring future generations to seek answers among the stars. As we reflect on the profound impact of Galileo's discoveries, we now move to another milestone that expanded the boundaries of our known solar system. Now turning to the year 1781, we arrive at a moment that forever changed our understanding of the solar system. the discovery of Uranus by William Herschel. Until this point in history, humanity believed the solar system consisted of only 6 planets visible to the naked eye: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Herschel, a musician turned astronomer, was using a custom-built telescope when he observed what he initially thought was a comet. However, careful analysis revealed it was something far more extraordinary: a new planet. This groundbreaking discovery was the first to be made with the aid of a telescope, shattering the millennia-old perception of a fixed and unchanging number of planets. Uranus, with its faint visibility and slow orbit, had eluded detection by ancient observers, but Herschel's keen observation skills and innovative tools brought it into light. This discovery did not merely add one more name to the list of celestial bodies. It expanded the scale of the known solar system and hinted at the possibility of even more planets awaiting discovery. It challenged astronomers to rethink the limits of our cosmic neighborhood and demonstrated the power of technology in exploring the heavens. The discovery of Uranus also inspired a surge in astronomical research, as scientists began to explore the idea that the cosmos was far more vast and dynamic than previously imagined. Herschel's work showcased how human ingenuity and curiosity could unlock secrets of the universe, setting the stage for future explorations that would push the boundaries of what was possible. As we marvel at the ambitious steps taken during this era, we now move forward to a transformative idea that would later reshape not just astronomy, but our very understanding of space, time, and gravity. Moving forward, we arrive at the year 1915, a time when a single revolutionary idea forever altered the course of science and our perception of the universe: Albert Einstein's theory of general relativity. This groundbreaking theory fundamentally redefined our understanding of gravity, presenting it not as a force between two objects as previously believed, but as the warping of space and time caused by massive objects like stars and planets. Einstein's equations explained phenomena that Newtonian physics could not, such as the precise orbit of Mercury and the bending of light by gravity, a prediction later confirmed during a solar eclipse in 1919, much to the astonishment of the scientific community. General relativity unveiled a universe that was dynamic, flexible, and interconnected in ways previously unimaginable. It provided the theoretical foundation for understanding the vast cosmological phenomena that shape our universe, from the expansion of space itself to the prediction of black holes, regions of space where gravity is so intense that nothing, not even light, can escape. This theory also laid the groundwork for the detection of gravitational waves, ripples in the fabric of space-time caused by massive cosmic events like the collision of black holes, a discovery that was finally confirmed over 100 years later in 2015. The impact of Einstein's work on modern astrophysics cannot be overstated. His insights continue to guide scientists as they explore the mysteries of the cosmos, assisting in everything from mapping the behavior of galaxies to advancing the technology behind space exploration. General relativity not only transformed physics but also expanded the limits of human imagination, reminding us that the universe operates on principles far more extraordinary than we once believed. With this monumental leap in our understanding of reality, we now turn our attention to an enigmatic event that showcases how Earth itself can be deeply affected by cosmic forces. Now turning to an event that remains one of the most mysterious and debated cosmic occurrences in modern history, we find ourselves in the remote Siberian wilderness of 1908. On the 30th of June that year, a massive explosion rocked the area near the Tunguska River, flattening over 2,000 square kilometers of forest and felling an estimated 80 million trees as if they were mere twigs. Witnesses described seeing a brilliant fireball streaking across the sky, followed by a thunderous detonation that was felt hundreds of kilometers away. The shockwave was so powerful that it shattered windows and knocked people off their feet in nearby towns. Yet, despite the devastation, no impact crater was ever found. This puzzling detail has led scientists to theorize that the explosion was caused by an astronomical event, likely a comet or asteroid that disintegrated in the atmosphere before reaching the ground. The most widely accepted explanation is that a stony asteroid, measuring about 50 to 60 meters in diameter, entered Earth's atmosphere at an incredible speed and exploded at an altitude of approximately 5 to 10 kilometers. The resulting blast released energy equivalent to about 15 megatons of TNT, roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima. Other theories range from a fragment of a comet composed mostly of ice vaporizing upon entry to more speculative ideas involving natural gas explosions or even extraterrestrial phenomena. Whatever the true cause, the Tunguska Event serves as a sobering reminder of Earth's vulnerability to cosmic impacts. It highlights the potential destructive power of relatively small celestial objects and underscores the importance of ongoing efforts to track and study near-Earth objects. This event also marked a turning point in our understanding of the risks posed by outer space, inspiring modern initiatives to develop asteroid detection systems and planetary defense strategies. From Siberia's enigmatic past, let us now journey to a period when the competition between two global powers would ignite humanity's first steps into the vast expanse of space. As the next challenge unfolds, we step into an era of unparalleled competition and innovation, the space race. Born out of the tense geopolitical rivalry between the United States and the Soviet Union during the Cold War, this high-stakes competition sought to showcase technological and ideological superiority. The space race began in earnest when the Soviet Union launched Sputnik 1 in 1957, the first artificial satellite to orbit Earth. This achievement sent shockwaves across the globe, particularly in the United States, where it was viewed as a potential threat to national security. It signaled that the Soviet Union not only had advanced technological capabilities, but could potentially develop intercontinental ballistic missiles capable of delivering nuclear warheads. This realization spurred the United States to accelerate its own space program, culminating in the creation of the National Aeronautics and Space Administration in 1958. The race was not just about technology, it was a proxy battlefield for the ideological clash between capitalism and communism. Each nation sought to outdo the other, pushing the boundaries of science and engineering at an unprecedented pace. The Soviets achieved several firsts, including sending the first human, Yuri Gagarin, into space in 1961, a feat that further intensified the competition. In response, the United States committed to an ambitious goal set by President John F. Kennedy to land a man on the moon and return him safely to Earth before the end of the decade. This declaration galvanized American efforts, leading to the Apollo program and its historic triumph with the Apollo 11 moon landing in 1969. The space race was far more than a contest for prestige. It fundamentally transformed the landscape of human knowledge and technological capability. Advancements spurred by this era led to satellite communication, global positioning systems, and innovations in materials science, many of which continue to impact our daily lives. Moreover, the intense focus on space exploration during this period inspired generations to look toward the stars with curiosity and ambition. The space race not only demonstrated humanity's capacity for rapid progress, but also highlighted the potential for international rivalry to drive scientific and technological breakthroughs. As we reflect on this transformative era, let us move forward to examine the initial spark that catapulted the world into the space age, a small satellite named Sputnik that forever changed the course of history. Now turning to the historic launch of Sputnik 1 in 1957, this small metallic sphere forever altered humanity's relationship with space. As the first artificial satellite to orbit Earth, Sputnik 1 symbolized the Soviet Union's technological prowess and marked the official beginning of the space age. Its impact was immediate and profound, shaking the cultural and scientific landscapes of nations around the globe. A groundbreaking feat, Sputnik 1 demonstrated that humanity was no longer bound to its home planet, proving it was possible to send objects into orbit and effectively opening the door to space exploration. The satellite itself, though modest in design, a polished aluminum alloy sphere just under 24 inches across with 4 spindly antennas, emitted a steady radio signal that could be detected by anyone with the right equipment. These beeping signals were not just a technological achievement but a clear message from the Soviet Union, announcing their dominance in the early chapters of space exploration. The launch of Sputnik 1 ignited a wave of scientific curiosity and innovation. In the United States, the event was perceived as a wake-up call, prompting significant investments in science and technology education, as well as the establishment of programs to accelerate American advancements in space exploration. This newfound urgency led to the creation of research initiatives and organizations dedicated to pushing the boundaries of human capability in space. Globally, Sputnik 1 inspired countless scientists, engineers, and even ordinary citizens to dream bigger and reach further. Its influence extended beyond space exploration, driving progress in telecommunications, weather forecasting, and scientific research. More than just a satellite, Sputnik 1 was a catalyst for a new era, proving that space exploration was not only possible but within humanity's grasp. As the echoes of its beeping signals faded into history, its legacy endured, shaping the ambitions of future generations and setting the stage for the awe-inspiring achievements that would follow. With the next phase of the journey in sight, let us turn our attention to the remarkable story of Yuri Gagarin, the first human to venture into the vastness of space. With the next phase of the journey in sight, we arrive at a truly historic moment in human history, Yuri Gagarin's groundbreaking journey into space in 1961. Yuri Gagarin, a 27-year-old Soviet pilot, became the first human to venture beyond the confines of Earth aboard the spacecraft Vostok 1. This extraordinary feat was achieved during a single orbit around the planet, lasting just under 109 minutes. Gagarin's mission was not only a testament to human ingenuity and courage, but also a powerful symbol of the Soviet Union's dominance in the ongoing space race. His spacecraft, Vostok 1, was a marvel of engineering for its time. Designed to carry a single cosmonaut, it was equipped with just enough technology to ensure survival and communication back to Earth. Gagarin himself had no control over the spacecraft, which was operated entirely by ground control, a stark reminder of the risks and uncertainties of early space travel. Despite this, his calm demeanor and iconic radio transmission, "I see Earth, it is so beautiful," captured the imagination of people worldwide. Politically, Gagarin's journey was a triumphant milestone for the Soviet Union, serving as a moment of national pride and solidifying their lead in the space race. It sent a clear message to the world about the Soviet commitment to space exploration and technological advancement. But beyond its political significance, this historic event held profound meaning for humanity as a whole. It demonstrated that human space travel was not only a dream but an achievable reality. For the first time in history, a person had broken free from Earth's atmosphere and glimpsed the vast expanse of space, a moment that irrevocably altered the course of human aspiration and exploration. Gagarin's mission inspired generations of scientists, engineers, and dreamers to push the limits of what was possible. The courage and vision required to undertake such a mission sparked a surge in global interest in space exploration, leading to advancements in technology and international collaborations that continue to shape our future among the stars. As we reflect on the significance of Yuri Gagarin's journey, we turn our gaze toward the next monumental achievement, one that brought humanity to an entirely new world, the first landing on the moon. With the next phase of the journey in sight, we arrive at one of humanity's most iconic achievements, the first moon landing in 1969. The Apollo 11 mission, led by NASA, marked the moment when Neil Armstrong and Buzz Aldrin became the first humans to set foot on the moon, while Michael Collins orbited above in the command module. On July 20th, the world held its breath as Armstrong descended the ladder of the lunar module, Eagle, and uttered the now famous words, "That's one small step for a man, one giant leap for mankind." This singular moment represented the culmination of years of relentless effort, innovation, and determination, not just for NASA but for humanity as a whole. The Apollo program required groundbreaking advancements in science and engineering technologies had to be invented from scratch, from the Saturn V rocket that propelled the astronauts into space to the intricate life support systems that kept them alive in the harsh environment of the moon. The landing itself was fraught with challenges, with Armstrong manually piloting the lunar module to a safe spot amid a field of rocks, demonstrating extraordinary composure and skill. Beyond the technical triumph, the moon landing had a profound impact on global culture. It united people across the world, with millions watching the live broadcast in awe, transcending national boundaries and political divisions. It was a moment of collective pride and wonder, a testament to what humans can achieve when driven by curiosity and ambition. The moon rocks returned by the astronauts provided invaluable insights into the moon's composition and history, revolutionizing our understanding of planetary science. Politically, the landing was a defining moment in the space race, showcasing the United States' technological prowess and solidifying its dominance in space exploration. Yet, more than a marker of geopolitical rivalry, the moon landing symbolized humanity's ability to dream beyond its earthly confines and to achieve the seemingly impossible. It inspired generations of scientists, engineers, and dreamers to look beyond the horizon, fueling advancements in fields ranging from computer technology to material science. As the Apollo 11 crew safely returned to Earth, they carried with them not just lunar samples but a new perspective, a reminder that our planet is but a small, fragile home in the vast cosmic expanse. Reflecting on the awe and inspiration of the moon landing, we move forward to explore another revolutionary milestone, an extraordinary eye in the sky that forever changed the way we see the universe, the launch of the Hubble Space Telescope. With the next phase of the journey in sight, we turn our attention to the remarkable launch of the Hubble Space Telescope in 1990, a milestone that transformed our understanding of the cosmos. Designed to operate beyond the distortion of Earth's atmosphere, Hubble offered a crystal-clear view of the universe unlike anything humanity had ever seen before. Its journey began aboard the Space Shuttle Discovery, and once it settled into orbit, this extraordinary instrument opened an unprecedented window to the stars. Equipped with a powerful mirror and advanced imaging tools, Hubble captured breathtaking images of galaxies, nebulae, and distant planets, providing scientists and the general public alike with a front-row seat to the wonders of space. Among its most iconic contributions are the jaw-dropping photographs of the pillars of creation, nestled within the Eagle Nebula, and the astonishing Hubble Deep Field, which revealed thousands of galaxies in a seemingly empty patch of sky. These images did not just awe and inspire, they fundamentally altered our perception of the universe's vastness and complexity. Beyond its visual achievements, Hubble answered critical questions about the cosmos. It measured the universe's rate of expansion with unparalleled precision, offering new insights into its age and the mysterious force known as dark energy. It also provided crucial data about the formation of stars, the nature of black holes, and the composition of distant exoplanets, despite initial setbacks, including a flawed mirror that required an ambitious and intricate repair mission in 1993. Hubble became a symbol of resilience and human ingenuity. Its success was a testament to the collaboration between engineers, astronauts, and scientists who refused to give up on its potential. For over 3 decades, Hubble has remained active, its contributions continuing to shape our understanding of the universe's structure and origins. It has not only advanced astronomy but has also bridged the gap between science and the public, sparking curiosity and wonder in millions. As we marvel at the legacy of this extraordinary telescope, we prepare to move forward to another chapter in the history of space exploration, a tragic moment that reminded us of the inherent risks of pushing human boundaries, the Space Shuttle Columbia disaster. As the next challenge unfolds, we arrive at a somber chapter in space exploration, the tragic loss of the Space Shuttle Columbia in 2003. During what was supposed to be a routine re-entry into Earth's atmosphere, Columbia disintegrated, taking the lives of all 7 crew members on board. The cause of this devastating accident was traced back to damage sustained during launch, when a piece of insulating foam broke off and struck the shuttle's left wing. This breach in the thermal protection system went undetected for the duration of the mission, ultimately leading to the shuttle's destruction upon its return to Earth. The disaster sent shockwaves through the global community, serving as a stark reminder of the inherent dangers of space exploration. It was not only a time of profound grief, but also one of intense reflection, as NASA and other space agencies across the world re-evaluated their priorities, practices, and the balance between ambition and safety. The Columbia tragedy marked a turning point, compelling major advancements in spacecraft design and operational protocols. A renewed emphasis was placed on pre-launch inspections, real-time monitoring, and the development of contingency plans to address potential damage during missions. The disaster also underscored the need for transparent communication and collaboration among teams to ensure that even minor issues are not overlooked. While the loss of Columbia and its crew remains a heartbreaking moment in space history, its legacy can be seen in the safety measures and innovations that emerged in the years that followed. These changes have not only made space exploration safer, but have also reinforced the resilience of the human spirit in the face of great adversity. As we pause to honor the bravery of those who perished aboard Columbia, we turn our gaze to the next leap in space exploration, a discovery that forever changed our perspective on worlds beyond our own, the identification of planets orbiting stars outside our solar system. Now turning to one of the most groundbreaking discoveries in modern astronomy, we delve into the identification of the first confirmed exoplanet in 1992. This remarkable milestone was achieved by astronomers Alexander Wolskson and Dale Frail, who detected a planet orbiting a pulsar, an ultra-dense, rapidly spinning remnant of a dead star. This discovery shattered long-held assumptions and sparked a new era of exploration beyond the boundaries of our solar system. For the first time, humanity had tangible evidence that planets exist around other stars, opening the door to endless possibilities about the nature and diversity of the cosmos. The early discoveries of exoplanets were just the beginning. As technology advanced, instruments like the Kepler Space Telescope revolutionized our ability to identify distant worlds. Kepler alone unveiled thousands of exoplanets, some of which reside in the so-called habitable zone around their stars, where conditions might allow liquid water to exist. These findings have fueled the tantalizing prospect of discovering Earth-like planets that could potentially support life. The search continues today with missions such as the Transiting Exoplanet Survey satellite, which scans nearby stars for signs of orbiting planets. In addition, innovations like the upcoming James Webb Space Telescope promise to delve even deeper into the atmospheres of these distant worlds, searching for chemical signatures that might hint at biological activity. The discovery of exoplanets has fundamentally reshaped our understanding of the universe, challenging the notion that our solar system is unique and raising profound questions about the prevalence of life beyond Earth. As we contemplate the vast number of stars in the galaxy and the potential billions of planets orbiting them, this discovery has not only expanded the frontiers of science, but also reignited timeless questions about our place in the cosmos. With this exploration of new worlds, let us now journey further into the timeline of space history, where we encounter a spacecraft that has ventured farther than any human-made object before, breaking through the boundaries of our solar system. Now turning to a historic milestone in humanity's exploration of the cosmos, we arrive at the incredible journey of Voyager 1. Launched in 1977 as part of NASA's groundbreaking Voyager program, this spacecraft set out to explore the outer planets of our solar system. Initially, it dazzled scientists and the public alike with detailed images and invaluable data from Jupiter and Saturn, revealing the complex beauty of these distant worlds, including Saturn's rings and the turbulent atmosphere of Jupiter. However, Voyager 1 mission was far from over. In 2012, it achieved something no other human-made object had done before. It crossed the heliopause, the boundary where the sun's influence ends and interstellar space begins. This moment marked humanity's first physical venture beyond the confines of the solar system, expanding our presence into the vast unknown. The spacecraft's groundbreaking achievement provided scientists with a treasure trove of data about the outer limits of our solar system, including insights into cosmic rays and the interstellar environment. But Voyager 1 is not just an engineering marvel, it is also a messenger of humanity. It carries the iconic Golden Record, a time capsule of Earth sounds, music, and greetings in multiple languages, intended to communicate the story of our world to any extraterrestrial civilization that might encounter it. As it continues its silent journey deeper into interstellar space, Voyager 1 stands as a testament to human ingenuity, curiosity, and the desire to explore the unknown. Its legacy inspires future generations to dream of reaching even farther into the cosmos. Now, as we reflect on humanity's first step into interstellar space, let us move forward to another transformative event in space history, one that reminded us of the risks and responsibilities tied to our exploration of the stars. As the next challenge unfolds, we revisit one of the most tragic and transformative moments in the history of space exploration, the Space Shuttle Challenger disaster. On a cold January morning in 1986, the Challenger lifted off from Kennedy Space Center, carrying 7 astronauts, including Krista McAuliffe, a school teacher who was set to become the first civilian in space. Millions of people watched with excitement as the shuttle ascended into the sky, a symbol of human ambition and the promise of space exploration. However, 73 seconds into the flight, tragedy struck. A critical failure in one of the solid rocket boosters caused the shuttle to break apart, resulting in the loss of all 7 crew members. The disaster sent shockwaves across the world and left an indelible mark on the collective memory of humanity. Investigations into the Challenger tragedy revealed critical flaws in decision-making processes and technical designs. Engineers had expressed concerns about the O-ring seals in the rocket boosters, which were susceptible to failure in low temperatures. Unfortunately, these warnings were overlooked, resulting in catastrophic consequences. This sobering event became a turning point for NASA and the entire space industry, emphasizing the harsh realities and risks of space exploration. In the wake of the disaster, NASA halted all shuttle missions for nearly 3 years, dedicating this time to an exhaustive review of safety protocols and engineering practices. The Challenger disaster led to significant changes in how space missions were planned, managed, and executed. New safety measures were introduced, including improved designs for the solid rocket boosters, more rigorous risk assessments, and an overhaul of NASA, a communication culture to ensure that concerns raised by engineers and staff would never again be ignored. Beyond the technical and organizational changes, the Challenger tragedy also had a profound impact on public perception of space exploration. It served as a stark reminder of the immense challenges and dangers associated with venturing beyond Earth. Yet, it also reinforced the resilience of the human spirit. The legacy of the Challenger crew continues to inspire, reminding us of the courage and dedication required to push the boundaries of human achievement. As we reflect on this somber chapter in space history, we honor the lives lost and the lessons learned, lessons that continue to shape the way we approach the exploration of the cosmos. Now, with these lessons in mind, let us move on to celebrate the triumphs of humanity's robotic ambassadors on Mars, whose groundbreaking discoveries have brought us closer to understanding the mysteries of the Red Planet. Now turning to the next chapter of space exploration, we celebrate the incredible achievements of humanity's robotic pioneers on Mars. The Mars rovers, including Spirit, Opportunity, and Perseverance, have transformed our understanding of the Red Planet, bringing it from a distant, mysterious world to one brimming with possibilities. In 2004, NASA made history with the twin rovers Spirit and Opportunity, which landed on opposite sides of Mars. Their mission was to search for evidence of ancient water, and they succeeded beyond expectations. Opportunity, in particular, operated for almost 15 years, far surpassing its intended 90-day mission, and uncovered signs that liquid water once flowed on Mars, revealing environments potentially capable of supporting life. Years later, Perseverance carried this legacy forward when it landed in Jezero crater in 2021. This advanced rover is not only analyzing Martian soil and rock to uncover the planet's geological history, but it is also actively searching for signs of ancient microbial life. Equipped with groundbreaking technology, Perseverance is collecting samples that could one day be brought back to Earth for more detailed study. What makes this mission even more extraordinary is its companion, Ingenuity, a small helicopter that became the first craft to achieve powered flight on another planet. This opens up new possibilities for aerial exploration on Mars and beyond. The accomplishments of these rovers have not only deepened our understanding of Mars as a planet, but have also brought us closer to answering one of humanity's most profound questions: are we alone in the universe? Through their tireless work on the Martian surface, these robotic explorers have laid the groundwork for future human missions, paving the way for a new era of exploration. As we marvel at the groundbreaking discoveries on Mars, our journey beyond Earth continues, this time taking us even closer to the enigmatic giants of the cosmos. Now turning to one of the most monumental achievements in modern astrophysics, we arrive at the historic moment in 2019 when humanity captured its first ever photograph of a black hole. For decades, black holes remained mysterious and theoretical, objects that could be studied only through indirect evidence like their gravitational pull on nearby stars or gas. But this all changed with the Event Horizon Telescope, a global network of radio telescopes working together as one to achieve unprecedented observational power. By focusing on the supermassive black hole at the center of the galaxy Messier 87, scientists achieved what many thought impossible: a direct image of a black hole's shadow surrounded by glowing, spiraling hot gas. This breakthrough was not only visually stunning but also scientifically profound, providing direct evidence to confirm predictions made by Albert Einstein's theory of general relativity. The so-called Ring of Fire revealed the black hole's event horizon, the boundary beyond which nothing can escape, not even light. This achievement marked a new era in our understanding of these cosmic giants, offering the most tangible glimpse yet into the extreme physics that govern black holes. It also showed how international collaboration and cutting-edge technology could unite to address some of the universe's most complex mysteries. As we continue to examine these colossal forces, the first photograph of a black hole serves as a powerful reminder of how far human curiosity and ingenuity can take us, inspiring future explorations of the unknown. Moving forward, our journey into space takes us to the International Space Station, a shining symbol of global cooperation and human ambition orbiting high above Earth. With the next phase of the journey in sight, we turn our attention to the International Space Station, a remarkable feat of human collaboration and ingenuity that has been orbiting our planet since the late 1990s. The International Space Station stands as a testament to what humanity can achieve when nations work together toward a common goal. Born out of the combined efforts of 15 countries, including the United States, Russia, Japan, and European nations, this massive structure serves as both a laboratory and a home for astronauts from around the globe. The station itself is an engineering marvel, spanning over the length of a football field and orbiting Earth at a speed of nearly 17,500 miles per hour. It was built piece by piece in space, with each module added over time through carefully coordinated missions, showcasing the precision and dedication of the teams involved. Beyond its impressive design, the International Space Station has become a hub for groundbreaking scientific research. From studying the effects of long-term space travel on the human body to developing innovative materials and technologies that benefit life on Earth, the station has opened doors to discoveries that were once beyond our reach. It has also played a critical role in fostering global diplomacy, providing a neutral ground where nations can set aside political differences and unite in the pursuit of scientific progress. Perhaps one of the most inspiring aspects of the International Space Station is the way it highlights the shared curiosity and ambition that bind humanity together. As it continues to circle our planet, the station remains a powerful symbol of our collective potential to explore the unknown and push the boundaries of what is possible. Now, from this enduring emblem of cooperation and discovery, we shift our focus to the revolutionary advancements in space exploration brought forth by SpaceX's Falcon Heavy launch. Now turning to the groundbreaking achievements of SpaceX, the 2018 launch of the Falcon Heavy rocket stands as an extraordinary milestone in the history of space exploration. As one of the most powerful rockets ever built, its debut captivated audiences worldwide and showcased the immense potential of private enterprise in advancing humanity's reach into space. Developed by SpaceX, founded by entrepreneur Elon Musk, the Falcon Heavy was designed to lift heavier payloads than ever before, making it a game-changer for deep space missions and commercial ventures alike. This rocket is essentially 3 rockets merged into one, with 27 engines working in perfect synchronization to generate over 5 million pounds of thrust. To put that into perspective, this is roughly equivalent to the thrust of 18 Boeing 747 airplanes at full power. What truly set this mission apart, however, was its bold and unconventional payload, a red Tesla Roadster, complete with a mannequin named Starman in the driver's seat. This whimsical cargo, launched on a trajectory to orbit the Sun, not only demonstrated the Falcon Heavy's capabilities but also captured the imagination of millions, blending serious innovation with a sense of playfulness. The Falcon Heavy launch also marked the beginning of a new era in space exploration, one where private companies could compete on a scale previously dominated by government space agencies. By significantly reducing the cost of access to space with reusable rocket technology, SpaceX paved the way for more frequent and affordable launches, enabling new opportunities for scientific research, satellite deployment, and even the dream of interplanetary colonization. This achievement underscored the transformative role of private industry in expanding humanity's presence beyond Earth, challenging traditional boundaries and inspiring a new generation of explorers and innovators. With the Falcon Heavy soaring to unprecedented heights, the stage was set for a surge of commercial activity in space that continues to unfold today. As we marvel at this revolutionary leap, our journey now takes us to the Cassini spacecraft and its unforgettable grand finale, which brought Saturn and its mesmerizing moons into sharper focus than ever before. Now turning to the awe-inspiring journey of the Cassini spacecraft, its grand finale in 2017 was a bittersweet yet monumental moment in the history of space exploration. After 2 decades of service, Cassini ended its mission by diving into the atmosphere of Saturn in a deliberate act of self-destruction, ensuring it would not contaminate the pristine moons it had studied so extensively. Launched in 1997 as a collaborative effort between NASA, the European Space Agency, and the Italian Space Agency, Cassini was designed to revolutionize our understanding of Saturn, its iconic rings, and its diverse collection of moons. Over the course of its mission, it did far more than anyone could have anticipated. Cassini delivered breathtaking images and vital data, unveiling stunning details about Saturn's atmosphere, the complex structure of its rings, and the dynamic environments of its moons. Among its most groundbreaking discoveries was evidence of subsurface oceans on moons like Enceladus, where jets of water vapor and ice particles were observed erupting from the moon's surface, hinting at the possibility of microbial life. Cassini also provided invaluable insights into the thick, hazy atmosphere of Titan, Saturn's largest moon, which boasts rivers, lakes, and seas of liquid methane and ethane. By deploying a lander known as Huygens, which touched down on Titan's surface in 2005, Cassini offered humanity its first close-up look at the surface of a world beyond our own. The spacecraft's grand finale, often referred to as the Cassini Grand Finale, was a meticulously planned series of daring maneuvers that began earlier in 2017. Cassini made 22 passes through the gap between Saturn and its rings, collecting unprecedented data before its final plunge. This dramatic conclusion was not just a spectacular end to the mission, but also a final act of scientific generosity, as the spacecraft transmitted critical data right up until the moment it disintegrated in Saturn's atmosphere. The legacy of Cassini is profound, as it forever changed our understanding of planetary systems and set the stage for future missions to explore the possibility of life on other icy moons. As we bid farewell to this remarkable mission, we now turn our attention toward one of the deepest mysteries of the universe, the role of dark matter, and how it continues to reshape our understanding of the cosmos. Now turning to one of the greatest enigmas of modern astrophysics, the role of dark matter stands as a cornerstone in unraveling the mysteries of the universe. First proposed in the 1930s by Swiss astronomer Fritz Zwicky, dark matter is an invisible substance that does not emit, absorb, or reflect light, making it impossible to observe directly. Yet its effects are undeniable. Scientists have observed that galaxies rotate at speeds that cannot be explained by the visible matter alone, and clusters of galaxies are held together by a gravitational force far greater than what their luminous content accounts for. This discrepancy pointed to the existence of something massive and unseen dark matter. Estimates suggest that it makes up roughly 85% of the total mass of the universe, yet its exact nature remains one of the most tantalizing puzzles in science. To detect its presence, researchers look to its gravitational influence on celestial objects and phenomena, such as the bending of light, known as gravitational lensing, where light from distant galaxies is distorted as it passes through massive clusters of dark matter. This phenomenon not only confirms the existence of dark matter, but also provides valuable clues about its distribution throughout the universe. Over the decades, scientists have developed numerous theories about what dark matter might be. Some suggest it is composed of hypothetical particles that interact weakly with other matter, while others propose exotic substances unknown to current physics. Laboratories deep underground are trying to catch these elusive particles using ultra-sensitive detectors shielded from external interference. Despite decades of research, dark matter still defies direct observation. Yet its importance is undeniable as it shapes the universe on the largest scales. Without it, galaxies as we know them would not form, stars would scatter, and the cosmos would look vastly different. The study of dark matter is not just about understanding its composition, but about unlocking deeper truths about the universe itself. As researchers continue to search for answers, dark matter remains the silent architect of cosmic evolution, challenging our perceptions and inspiring new questions about the unseen forces that govern the universe. Next, we move from the shadows of dark matter to a revolutionary step in space exploration, the creation of the reusable SpaceX Dragon capsule and how it transformed the way humanity approaches space travel. Now turning to a revolutionary milestone in space exploration, the birth of the SpaceX Dragon capsule redefined humanity's approach to venturing beyond our planet. Developed by Space Exploration Technologies Corporation, better known as SpaceX, the Dragon capsule was a bold step towards making space travel more sustainable and cost-effective. Its story begins with a vision to create a reusable spacecraft capable of transporting both cargo and crew to destinations such as the International Space Station and eventually beyond. In 2010, the Dragon capsule made history as the first commercially developed spacecraft to be successfully recovered after orbiting Earth, proving that private companies could achieve what had long been the domain of government space agencies. Then, in 2012, it reached another groundbreaking milestone by becoming the first commercial spacecraft to dock with the International Space Station, delivering supplies and returning cargo safely back to Earth. But it was not just the technological achievement that left its mark. The Dragon capsule symbolized a new era of public-private partnerships in space exploration. Its ability to be reused multiple times drastically lowered the cost of access to space, a critical step toward the dream of making space travel more accessible. The design of the Dragon capsule is nothing short of innovative. It is equipped with advanced heat shields to endure the searing temperatures of re-entry, a spacious interior to accommodate both supplies and human passengers, and the agility to navigate independently in orbit. In fact, its successor, known as the Crew Dragon, made another historic leap in 2020 by carrying astronauts to the International Space Station from American soil, the first such flight since the conclusion of the Space Shuttle program in 2011. This journey marked the return of human spaceflight capabilities to the United States and demonstrated the potential of commercial space travel. The Dragon capsule did not just revolutionize how humans approach space exploration, it ignited a wave of interest and investment in the commercialization of space. By proving that reusable spacecraft are feasible and reliable, it paved the way for future missions to the Moon, Mars, and beyond. As humanity continues to dream of traveling farther into the cosmos, the Dragon capsule stands as a testament to what can be achieved when innovation and ambition collide. Moving forward, we shift our focus to a tantalizing goal of space exploration: the search for water on other planets, and how these discoveries could unlock clues to the existence of life beyond Earth. As the next challenge unfolds, the search for water on other planets has become one of the most intriguing quests in modern space exploration. Water, the cornerstone of life as we know it, holds the key to answering some of humanity's most profound questions. Is there life beyond Earth? And could humans one day call another celestial body home? Let us begin with Mars, often referred to as the Red Planet. Over the years, robotic missions and orbiters have uncovered compelling evidence of water on Mars. From vast ancient river valleys and lake beds to the discovery of water ice at its poles and even beneath its surface, these findings suggest that Mars once had conditions favorable for life. More recently, radar data hinted at a possible subglacial lake beneath its southern ice cap, igniting even greater curiosity about its potential to harbor microbial life today. Beyond Mars lies Europa, one of Jupiter's moons. Europa is wrapped in a thick layer of ice, but beneath that icy shell exists an enormous saltwater ocean, kept liquid by the moon's internal heat. Scientists believe this hidden ocean may contain twice as much water as all of Earth's oceans combined, making it one of the most promising candidates in the search for extraterrestrial life. The tantalizing possibility of hydrothermal vents on Europa's ocean floor, similar to those on Earth where life thrives in total darkness, further fuels this hope. Then there is Enceladus, a smaller moon of Saturn, which stunned scientists when the Cassini spacecraft captured geysers of water vapor erupting from its icy surface. These plumes contain organic molecules and hint at another subsurface ocean, raising fascinating possibilities about habitability. Even on the Moon, Earth's closest neighbor, traces of water have been found in the form of ice in permanently shadowed craters at its poles. This discovery has significant implications for future human colonization, as lunar water could provide a vital resource for drinking, farming, and even producing rocket fuel. Each of these discoveries is a stepping stone toward understanding the universe's potential for life. The presence of water on these celestial bodies not only broadens our understanding of where life might exist, but also plays a pivotal role in shaping future exploration missions. As we continue to probe the cosmos, the search for water remains central to our vision of embarking on interplanetary journeys, and perhaps one day transforming other worlds into homes for humanity. With this groundbreaking mission in mind, we now turn our attention to the Parker Solar Probe and its unprecedented journey to study the Sun, unlocking the secrets of the star that sustains life on Earth. Moving forward, we delve into one of the most daring missions ever embarked upon, NASA Parker Solar Probe. Launched in the year 2018, this trailblazing spacecraft set out with an audacious goal to touch the Sun. As it journeys closer to our star than any spacecraft in history, the Parker Solar Probe is revolutionizing our understanding of solar activity and its profound impact on Earth. The Sun, though more than 90 million miles away, governs life on our planet in ways we are only beginning to fully grasp. From driving our climate and weather to fueling the auroras that dance across polar skies, its influence is paramount. Yet, its searing heat and intense radiation have kept many of its mysteries just out of reach until now. Equipped with advanced instruments capable of withstanding temperatures exceeding 2,500 degrees Fahrenheit, the Parker Solar Probe is venturing through the Sun's outer atmosphere, known as the corona, to study its behavior up close. One of its primary objectives is to unravel a centuries-old mystery: why the corona, the Sun's outermost layer, is millions of degrees hotter than its surface. Understanding this phenomenon could unlock the secrets of solar wind, a stream of charged particles that influences space weather. Space weather, although invisible to the naked eye, can wreak havoc on Earth's technology. It has the power to disrupt global communication systems, GPS networks, and even electrical grids. By analyzing the mechanisms driving solar wind and solar flares, the Parker Solar Probe provides critical data that will help scientists predict space weather events with greater accuracy, safeguarding our planet against potential disruptions. Beyond practical applications, the probe's findings are reshaping humanity's understanding of how stars function, shedding light on the forces that have shaped our solar system and countless others across the cosmos. Each layer of data transmitted back to Earth brings us closer to decoding the Sun's complex dynamics, paving the way for a future where solar activity is no longer an enigma but a well-understood phenomenon. With its groundbreaking mission ongoing, the Parker Solar Probe reminds us of the boundless potential of human ingenuity when faced with the universe's greatest challenges. As we marvel at this daring journey to our star, we now direct our gaze back into the expanse of space to uncover the countless distant worlds revealed by the discoveries of the Kepler Space Telescope. With the next phase of the journey in sight, we turn our attention to a mission that transformed our understanding of the cosmos, the Kepler Space Telescope. Launched in the year 2009, Kepler was designed with one primary purpose: to explore the vast expanse of our galaxy in search of planets beyond our solar system. These planets, known as exoplanets, hold the key to answering one of humanity's most profound questions. Are we alone in the universe? Before Kepler, scientists had identified only a handful of exoplanets using indirect methods, but their existence still seemed elusive. Kepler changed everything by staring unwaveringly at a single patch of sky, continuously monitoring the brightness of over 150,000 stars. Its method was simple yet revolutionary. It searched for tiny dips in a star's light, which could indicate a planet passing in front of it, an event known as a transit. This technique enabled Kepler to detect planets of all sizes, from gas giants larger than Jupiter to rocky, Earth-like worlds. Over its 9-year journey, the Kepler mission discovered more than 2,600 confirmed exoplanets and identified thousands of additional candidates, effectively reshaping our understanding of planetary systems. These findings revealed that planets are not the exception, but the rule. Most stars in our galaxy are likely orbited by one or more planets. Perhaps most compelling were the discoveries of planets residing in the so-called habitable zone, where conditions might allow for liquid water, a crucial ingredient for life as we know it. Kepler's groundbreaking work demonstrated that Earth-like planets could be surprisingly common, reigniting hopes in the search for extraterrestrial life. Beyond individual discoveries, the telescope revolutionized our understanding of planetary formation and diversity. It uncovered worlds far stranger than anyone had imagined, including planets with scorching, molten surfaces, others shrouded in thick atmospheres of gas, and some that orbit two stars instead of one, like the fictional planet Tatooine from Star Wars. Each discovery added a piece to the cosmic puzzle of how planets form, evolve, and interact within their systems. Even after its retirement in 2018, Kepler's legacy endures as a cornerstone of modern astronomy. The vast database it left behind continues to fuel new discoveries and inspire future missions like its successor, the Transiting Exoplanet Survey satellite, which carries forward the torch of planetary exploration. As we reflect on Kepler's monumental contributions to science, we are reminded of how far humanity has come in its quest to understand the universe and how much more there is to uncover. Now, with our sights set on even greater cosmic mysteries, we prepare to explore the promises of the next great observatory, the James Webb Space Telescope. With the next phase of the journey in sight, we turn our focus to the James Webb Space Telescope, a marvel of modern engineering and the most ambitious observatory ever launched into space. Deployed in the year 2021, this telescope is designed to peer farther into the universe than any instrument before it, unlocking secrets from the dawn of time. Where its predecessor, the Hubble Space Telescope, gave us stunning glimpses of galaxies and nebulae, the James Webb Space Telescope takes us even deeper, with capabilities tailored for uncovering the faintest light from the universe's earliest moments. It is equipped with an extraordinary array of infrared instruments, allowing it to see through dense clouds of gas and dust, regions where stars and planets are born, and detect faint signals emitted billions of years ago. This enables scientists to study some of the oldest galaxies formed after the Big Bang, helping to piece together the puzzles of cosmic evolution. But the telescope's mission is not just about looking back in time, it is also about exploring worlds much closer to home. The James Webb Space Telescope is capable of analyzing the atmospheres of exoplanets, searching for signs of water vapor, methane, carbon dioxide, and even potential biosignatures that could indicate life. By examining planets in the habitable zones of distant star systems, it raises hopes of answering one of humanity's most pressing questions: are we truly alone? Unlike any observatory before, this telescope provides unparalleled detail, capable of studying the chemical fingerprints of celestial objects across vast distances. Its unique position, stationed nearly 1 million miles from Earth at a stable point known as the second Lagrange point, ensures uninterrupted and precise observations as it gazes into the depths of space. This distant location minimizes interference from heat and light, allowing for incredibly sensitive readings that were once unimaginable. The telescope's intricate design, including its massive, gold-coated mirror made up of 18 segments, represents years of collaboration, innovation, and determination from scientists and engineers worldwide. Already, the James Webb Space Telescope has begun to transform our understanding of the universe, capturing breathtaking images of galaxies colliding, stars being born, and mysterious phenomena that challenge our current theories. Each observation it makes brings us one step closer to comprehending the grand scale of the cosmos and our place within it. As this new era of discovery unfolds, we stand on the brink of revelations that could redefine everything we know about space, time, and life itself. Moving forward, we set our sights on the ongoing pursuit of uncovering intelligent extraterrestrial life, a quest that has captivated human curiosity for generations. Now turning to the search for intelligent extraterrestrial life, humanity's fascination with the possibility of not being alone in the universe has inspired some of the most ambitious scientific endeavors in history. One of the earliest and most iconic moments in this quest came in 1977 with the discovery of the WOW signal, a mysterious burst of radio waves detected by a radio telescope in Ohio. This signal, lasting only 72 seconds, was so unusual that an astronomer famously scribbled the word "wow" next to the data, giving it its name. To this day, it remains one of the most compelling, unexplained events in the search for extraterrestrial intelligence, fueling hope and curiosity about whether it might have originated from a distant alien civilization. The WOW signal was just the beginning of efforts to tune into potential extraterrestrial communication. For decades, projects like the Search for Extraterrestrial Intelligence, or simply SETI, have scanned the cosmos for signals that defy natural explanations. Using some of the world's most powerful radio telescopes, scientists analyze vast amounts of data for patterns or anomalies that might suggest an intelligent origin. These searches rely on the idea that advanced civilizations, if they exist, might use electromagnetic waves as a form of communication, much like we do on Earth. Beyond radio signals, newer technologies and methods are broadening the horizons of this search. Optical SETI, for example, explores the possibility that extraterrestrials might use visible light, such as laser bursts, to communicate. Even more intriguing is the idea of technosignatures, which involves searching for evidence of advanced technology, like artificial megastructures or pollution in the atmospheres of distant planets that could only be produced by intelligent life. The implications of finding intelligent extraterrestrial life would be profound, potentially answering one of humanity's greatest existential questions while fundamentally altering our understanding of the universe and our place within it. It would force us to rethink everything from our scientific theories to philosophical and even theological beliefs. However, the absence of definitive evidence so far raises other questions. Are intelligent civilizations exceedingly rare, or are we simply looking in the wrong way or at the wrong time? Despite these challenges, the search for intelligent extraterrestrial life continues to inspire scientists and stargazers alike. Each signal analyzed, each new method developed, represents not just a step toward potentially making contact, but also an expansion of our own knowledge and technological capabilities. As this cosmic pursuit unfolds, it reminds us that even the act of searching connects us to something greater, reflecting humanity's enduring curiosity and hope. As our exploration of the universe deepens, we now shift our focus to another groundbreaking mission that brought us closer to understanding the building blocks of our solar system, the incredible Rosetta mission. Now turning to the remarkable Rosetta mission, this groundbreaking achievement in space exploration reached an extraordinary milestone in 2014 when the Rosetta spacecraft successfully landed its probe Philae on Comet 67P. This marked the first time in history that a spacecraft had landed on the surface of a comet, a feat that captured the imagination of people around the world. The mission, led by the European Space Agency, was designed to unlock secrets about the early solar system by studying these ancient cosmic remnants, which are often described as time capsules from the dawn of planetary formation. Rosetta spent over a decade traveling through space to reach the comet, an icy body hurtling through the cosmos at speeds of up to 34,000 miles per hour. Once it arrived, the spacecraft orbited the comet, gathering unprecedented data and capturing stunning images of its rugged, alien landscape. The Philae lander added to this treasure trove of information by conducting experiments directly on the comet's surface, despite facing challenges like landing in a shadowy area that limited its solar power supply. The data collected by Rosetta and Philae provided groundbreaking insights into the composition and structure of comets. Scientists discovered complex organic molecules, hinting at the potential role comets may have played in delivering the building blocks of life to Earth billions of years ago. Additionally, the mission revealed fascinating details about the comet's activity, including how its surface changes as it approaches the Sun and begins to release gas and dust in a spectacular display. Beyond its scientific contributions, the Rosetta mission also showcased the incredible potential of international collaboration and advanced engineering. It pushed the boundaries of what humanity can achieve and demonstrated how exploring distant worlds can deepen our understanding of our own origins. As we bid farewell to Rosetta, which ended its mission in a controlled crash onto the comet's surface in 2016, its legacy continues to inspire future missions aimed at unraveling the mysteries of the cosmos. With our gaze still directed outward, we now turn to a cosmic collision that offered rare insights into planetary impacts, the awe-inspiring Great Comet Impact on Jupiter. Now turning to the extraordinary event of the Great Comet Impact on Jupiter, this unprecedented cosmic collision in 1994 was a moment that forever changed our understanding of planetary dynamics and celestial interactions. The comet, known as Shoemaker-Levy 9, broke apart into more than 20 fragments after being gravitationally captured by Jupiter during a previous orbit. These fragments, ranging from a few hundred meters to several kilometers in size, smashed into Jupiter's atmosphere over the course of 6 days, creating a spectacle that was observed by telescopes worldwide. The sheer scale of the impact was staggering. As the fragments collided with Jupiter, they released energy comparable to millions of tons of dynamite, producing massive fireballs that ascended above the planet's cloud tops. The largest impact left a scar larger than the size of Earth, a stark reminder of the immense forces at play in our solar system. Scientists were able to study these temporary scars in detail, gaining unprecedented insights into the composition of both the comet and Jupiter's atmosphere. The observations revealed elements like sulfur and ammonia from the planet's deeper layers, which were brought to the surface by the explosions. This event also served as a wake-up call about the potential threat posed by similar impacts on Earth. It underscored the importance of monitoring near-Earth objects and developing strategies to mitigate potential collisions. The Great Comet Impact sparked increased interest in planetary defense and highlighted the need for global cooperation in addressing these cosmic challenges. Beyond its scientific and practical implications, Shoemaker-Levy 9 collision with Jupiter captured the imagination of millions, offering a rare glimpse into the dramatic and often chaotic nature of our universe. It reminded us of the constant motion and interaction of celestial bodies, a dance that has shaped the solar system for billions of years and continues to influence its evolution. From this momentous event, we now journey to a groundbreaking milestone in space exploration that allowed a private citizen to experience the wonders of the cosmos, the historic first space tourist. Now turning to the incredible milestone of the first space tourist, we land in the year 2001 when Dennis Tito, an American engineer and entrepreneur, made history by becoming the first private citizen to journey into space. Tito's flight was aboard a Russian spacecraft called Soyuz, which took him to the International Space Station, a destination that had previously only been accessible to government astronauts and scientists. This groundbreaking adventure unfolded over nearly 8 days, during which Tito orbited Earth more than 100 times, experiencing the awe-inspiring beauty of our planet from above. What made this moment so transformative was not just the singular achievement of Tito himself, but the precedent it set for the future of space travel. For the first time, private individuals could imagine venturing into the cosmos, not as professional astronauts, but as paying customers. Dennis Tito's mission demonstrated that space was not only the domain of government programs, but also a frontier that could be opened to ordinary people with extraordinary ambitions. His journey, funded by his own wealth, was seen by many as the first step toward making the dream of space tourism a reality. This event spurred a wave of innovation as private companies began to explore the concept of commercial space travel. It planted the seeds for what would eventually blossom into a thriving space tourism industry, as companies like SpaceX and Blue Origin took inspiration from Tito's groundbreaking journey. His trailblazing adventure inspired visionaries to develop technology and infrastructure aimed at making space more accessible to humanity at large. Beyond its impact on the commercial space industry, Dennis Tito's voyage carried symbolic significance. It marked a profound shift in the narrative of space exploration, from one of national competition and scientific endeavor to one where individuals could play a direct role in exploring the final frontier. His story illustrated the democratization of space, offering a glimpse into a future where the cosmos may one day be a destination for people from all walks of life. As we reflect on this pivotal moment in history, it is clear that Dennis Tito's journey was not just a personal accomplishment, but a world-changing leap forward in how we view space travel. From this milestone, we now look ahead to an astonishing discovery that unveiled a cosmic clue to the origins and structure of the universe: the discovery of the cosmic microwave background radiation. Now turning to the groundbreaking discovery of the cosmic microwave background radiation, we step into a moment that forever changed our understanding of the universe's origins. In 1965, two scientists named Arno Penzias and Robert Wilson were conducting experiments with a large antenna designed for satellite communication. To their surprise, they encountered a persistent noise that they couldn't explain or eliminate, no matter how much they adjusted their equipment. Initially, they thought it might be interference from nearby sources or even issues like bird droppings on the antenna. However, as they delved deeper, they realized that this faint, uniform signal was coming not from a specific direction, but from every part of the sky. This mysterious signal turned out to be the cosmic microwave background radiation, a relic from the Big Bang itself, dating back nearly 14 billion years. It represents the faint glow of heat left over from the universe's earliest moments, when it was an unimaginably hot and dense state. What Penzias and Wilson had stumbled upon was essentially the afterglow of creation, a silent yet profound echo of the universe's birth. This discovery was not only monumental in confirming the Big Bang theory, but it also provided a snapshot of the infant universe, offering scientists a window into its earliest structure and evolution. The cosmic microwave background radiation revealed that the universe began as a hot, uniform expanse that gradually cooled and expanded. Detailed analysis of this radiation has since allowed scientists to map the tiny fluctuations in temperature that eventually led to the formation of galaxies, stars, and planets. It served as a cosmic blueprint, telling the story of how matter clumped together over billions of years to create the intricate structures we observe today. This discovery has helped refine our understanding of fundamental concepts, such as the distribution of matter, the rate of the universe's expansion, and the role of dark matter and dark energy. The impact of finding the cosmic microwave background radiation cannot be overstated. It cemented the Big Bang theory as the leading explanation for the origin of the universe and became one of the most significant scientific achievements of the 20th century. For their work, Penzias and Wilson were awarded the Nobel Prize in Physics, but the real reward was the wide-reaching implications of their discovery. It inspired generations of researchers to investigate deeper questions about the cosmos, such as what existed before the Big Bang and how the universe might ultimately end. As we consider this transformative moment, it becomes clear that the discovery of the cosmic microwave background radiation did more than just confirm a theory. It gave humanity a connection to the very beginning of everything we know, bridging the gap between past and present in the vast tapestry of the cosmos. And as we continue to explore the universe, this discovery serves as a reminder of how far we've come in unraveling its mysteries and how much further we still have to go. Now turning to the conclusion of our journey through these 30 monumental space events, it's remarkable to reflect on how each one has left an indelible mark on our understanding of the universe and our place within it. From the explosive origins of the cosmos to the delicate search for water on distant planets, we've uncovered stories of human ingenuity, scientific breakthroughs, and mysteries that continue to push us toward the unknown. These moments have not only expanded human knowledge but have also inspired generations to dream larger, reach further, and redefine the boundaries of possibility. They remind us that space is not just an expanse to explore, it's a mirror reflecting our curiosity, resilience, and unyielding quest for answers. Which of these historic events do you believe will spark the next great leap for humanity in space? Share your thoughts and favorite moments in the comments below. What do you think the future holds for our exploration of the cosmos? Let us know your visions of what's to come. If you've enjoyed this journey through the milestones of space history, don't forget to like this video, share it with fellow cosmic explorers, and subscribe to our channel for more incredible adventures through the vast wonders of the universe. Your support fuels our mission to keep uncovering the mysteries of the cosmos and sharing them with you. Thank you for joining us on this voyage through time and space, and until next time, keep looking up.